Okay, so now in this example, we are going to decrease the damping even more. So we're going to decrease the impact of the friction a little bit. So we started with B equals 5, and we had two real solutions. We decreased B to 4, and that was kind of this critical point where we still had real solutions. We just had one repeated real solution. And so the behavior in the long run is that that went back to its equilibrium without oscillating at all. So now let's decrease B even more, and now let's set it at 2. And let's see what the solution is going to be and how that solution is going to behave. So our characteristic equation, r squared plus 2r plus 4 is equal to 0. So this does not factor very cleanly. So if we were to use the quadratic formula, then we'd get minus 2 plus or minus the square root of 2 squared minus 4 times 1 times 4 all over 2 times 1. Just to write that out, and simplifying that, you would get that r is equal to minus 1 plus or minus the square root of 3 times I. And so what's important to note here is that the stuff inside underneath the square root, the discriminant we would say here is actually 4 minus 16. So we actually get a negative value underneath the square root. And that negative value gives us complex solutions. And let's write out what that would look like. So now our general solution would be C1 is equal to e to the minus t times the cosine of the square root of 3t plus C2 times e to the minus t times the sine of the square root of 3 times t. And then using our initial conditions, we could solve for these arbitrary constants, C1 and C2, and we get that C1 is going to equal 1 and that C2 is actually 1 over the square root of 3. And so now we get some combination of the kind of oscillation behavior that we get with trig functions, but we have these exponential terms out in front. So as t goes to infinity, this term is going to go to 0, and this term is going to bounce back and forth between plus or minus 1. So I have something going to 0 times something bouncing back and forth between plus or minus 1. So altogether, that term is going to go to 0. Same for this term, it's going to go to 0. So as t goes to infinity, these solutions are still going to go to 0 as t goes to infinity, but in a slightly different fashion. So let's uncover the solution over here. And what you can see is over here, what's happening now is that this mass is now passing over its equilibrium, going to the left, passing back over its equilibrium, going to the right. And what you can't see is that it's actually just having these really, really small oscillations as time goes on. So with this system, we do have oscillations. Okay, it's just the amplitude of those oscillations are going to 0. So each time it bounces back and forth, it's not going as far to the left or to the right as it did in the previous oscillation. And so since we do have some oscillations in this system, we would say that this one is actually underdamped. Okay, and that's because our solutions to the characteristic equation were complex. So we did get some mixture of trig functions and exponential functions. So we are getting some mixture of oscillating behavior, just those oscillations are getting less and less and less as time goes on. So let's summarize all of this in the next slide.